Hello and welcome to this chemistry lecture series. In this video, we're going to look at chapter 18.2, where we're going to look at how do we create or manufacture aldehydes and ketones, the reactions which have these two functional groups as a product. Now, in this section, we're going to look at two reactions, one to make aldehydes and one to make ketones. But in reality, we've already seen these reactions in chapter 17 when we studied the reactions of alcohol. So this section is a bit of a review from what we'd already seen. So let's get started. So the way in which we create aldehydes is by the oxidation of primary alcohols. In chapter 17, we looked at how if we grab a primary alcohol and we oxidize it, and this could either be with potassium dichromate or the other oxidizing agent, which is not mentioned here, but it would also work, being potassium permanganate. Now, if we grab acidified acidified potassium dichromate with dilute sulfuric acid, and we react a primary alcohol with it, we will oxidize that alcohol. We would add oxygens and remove hydrogens from that alcohol. This reaction has to happen in distillation. We talked about this already. When we do this reaction, one of the conditions, if we're trying to make an aldehyde, and I'm very clear on that, if we're trying to make an aldehyde, one of the conditions that we will have for this reaction is that it needs to be carried out through distillation. Remember that when we have aldehydes can also be oxidized. So if a primary alcohol reacts with potassium dichromate that has been acidified with sulfuric acid, and we react the primary alcohol into an aldehyde, the aldehyde that results from this can also be oxidized by the dichromate into a carboxylic acid. So we don't want the carboxylic acid. If we are trying to make an aldehyde, we need to undergo this reaction through or in distillation. Remember, distillation is going to prevent and separate that aldehyde when it forms. We have the alcohol with the acidified potassium dichromate, and because the boiling point of the aldehyde is going to be lower than the boiling point of the alcohol from which it's made, which is higher, if we heat up the reaction vessel, as the aldehyde, and I'm going to just label it with A, gets made, that aldehyde is going to evaporate into the gas phase as it gets heated up. The alcohol won't, because the reaction vessel will be at a lower temperature than the alcohol's boiling point. Once that aldehyde vaporizes, it goes through our distillation vessel and then condenses back into a liquid where it drips out into a separate container. That separates it from the dichromate that the alcohol is reacting with, and therefore we have the aldehyde that does not further oxidize into carboxylic acid. So the primary alcohols can be oxidized into our aldehydes, but only if distillation is present, or if not, we'll get a carboxylic acid if distillation is not present. Now, there is an observation that goes along with this, and that's right here. Remember that dichromate, anytime dichromate reacts, anytime dichromate oxidizes something, there's going to be an orange to green color change. Not precipitate, but a color change from orange to green. And that's because the dichromate is orange in color, the dichromate ion, but whenever dichromate reduces itself and oxidizes something else, it gets reduced into chromium 3+, which is green. So we're going to get an orange to green color change as our observation for this reaction when it happens. That is because we're doing a dichromate. Be aware that if we do this with permanganate, if we do this instead with K2Cr2O7, if we do it KMnO4, which is another strong oxidizing agent, then the observation we'll get is a purple to clear color change. But that's with the dichromate. With the potassium permanganate, that's with the potassium permanganate. With the dichromate, we'll get a orange to green color change as our observation. So this is again a review from chapter 17, where we saw the oxidation of primary alcohols into aldehydes and then carboxylic acids to get further oxidized. Always remember though, if the goal is to make an aldehyde, we absolutely have to carry out this reaction through distillation, or it won't work and we'll get the carboxylic acid instead. The exact same reaction can be used to create ketones instead of aldehydes. However, when we do this reaction to make ketones, instead of using a primary alcohol, we will be using a secondary alcohol. So when we do the exact same reaction with the dichromate, but instead we use a secondary alcohol, we'll get a ketone instead of the aldehyde. We'll still use dichromate. It still needs to be acidified with sulfuric acid as our reactants. Oops, let me make this a little smaller. So we'll still get the acidified dilute sulfuric acid with the potassium dichromate reacted with now a secondary alcohol. Because the alcohol is secondary, because that carbon is attached, that oxygen is attached to two other carbons on the carbon that it's attached to, we'll get the carbonyl group being created with two carbon chains on it. And that means a ketone instead of an aldehyde. The reason why primary alcohols create aldehydes, so I'm going to hide this for a second. The reason why primary alcohols create aldehydes is because the oxygen on a primary alcohol is on a terminal carbon. It's on the carbon at the end of the chain. So the carbonyl group on that aldehyde that's created, it's going to be on the terminal carbon, creating the aldehyde. However, with a secondary alcohol, the oxygen is on a carbon that already has two carbon atoms attached to it. So when the carbonyl gets made, it gets made in the middle of a chain, making a ketone instead of an aldehyde. This reaction does not need to be carried out with distillation. Distillation is not necessary when ketones are created, and that's because ketones cannot be oxidized. Aldehydes can be oxidized into carboxylic acids, but ketones cannot. And so we do not need to separate the ketone from the alcohol, and so distillation is not necessary for this reaction. We'll just get the ketone right away as our product. Now, we do still get the same observation here. There's still an orange to green color change for that dichromate, going from the dichromate ion to the Cr3 plus ion, the chromium 3 ion, as our observation. If we were to use again potassium permanganate instead of using the dichromate, because this reaction can also be done with KMnO4, then the color change we'll get is a purple to clear color change. But again, these are two sides of the same coin. These are the exact same reaction, but our initial alcohol is different. Primary gives you an aldehyde, secondary gives you a ketone, and tertiary alcohols can't be oxidized. So keep that in mind. These are the two different ways we can make these functional groups for both the ketones and the aldehydes. It's really the only reaction that we study in this class which can, or which are capable of creating the ketones and the aldehydes. All right. That is it for section 2. It was also a very short section, mostly a review from chapter 17. I will see you all in the next video to start discussing the reactions that ketones and aldehydes can undergo in section